Factoring trinomials, literally essential to understand if you ever want to do well in high school or college algebra. So let's learn how to do that, and I assure you it is not as hard as it may initially seem. So first we're going to look at how to factor a trinomial where the first coefficient, like the coefficient on the first term, is 1. So if you have something like x squared plus 7x plus 12, that's okay. And we can use this method, but if you have something like 4x squared plus 7x plus 12, that's going to use a different method because this coefficient, in order to use what I'm about to show you, has to be 1. So keep that in mind. So how do we factor this trinomial x squared plus 7x plus 12? Well, like all factoring, it's going to ultimately involve removing a greatest common factor. But if we look at this trinomial, there isn't really a clear greatest common factor, so it's going to take some manipulation to get there. So for our first step, we're going to look for some mystery variables, and we can call those a and b. Now, if you know like the standard equation for a trinomial, the ax squared plus bx plus c, those are not the same a and b. It's just easier than, it would be confusing to use x and y. You can use any variables you want, I don't care. I'm just going to use a and b. I hope that's not confusing. So, the rules for these variables are that a plus b is going to equal our middle term. So in this case, that's 7. And then a times b is going to equal our last term, or 12. And with the use of some minor brain power, we can figure out that a is equal to 3 and b is equal to 4, or vice versa. So for our next step, we're going to start splitting up some terms, and this will make the greatest common factors more clear. So we're going to have x squared, that stays the same, but then we're going to split the middle term. Remember, a plus b equals the middle term. So we're going to split 7x up into 3x and 4x. It's still 7x, it's just split up so we can see what it's made of better. And then we're still going to have 12x, but keep in mind that 12 is 3 times 4. And oh my god, it looks like we can factor by grouping now. So we're going to do that. So here we'll remove the GCF of x, so we'll have x times x plus 3. And then remove the GCF of 4 here, 4 times x plus 3. And then, just going to move that over there. We can remove the greatest common factor of x plus 3, and we get x plus 4 times x plus 3. And if that seemed like really confusing to you, in terms of removing the GCF and factoring by grouping, you can go back, this is in a playlist in my channel, and you can go back and watch my previous video on factoring by greatest common factor and factoring by grouping if you're confused. I think it's an okay explanation, and maybe you will too. Anyway, we did it. We're done. We factored it. And something you might notice is that in this expression x plus 4 times x plus 3, 4 and 3 are just our a and b variables. So if you're in a hurry and you don't want to do all of these steps, all you would really need to do is figure out what a and b is, and then you can turn something like this into just x plus a times x plus b. And it's good to keep in mind that if this were instead x squared minus 7x, this might be x minus a times x plus b, or x minus a times x minus b. So just keep the signs in mind, but it pretty much works for everything as long as the coefficient of the x squared term is 1. Personally, I like to do it out when I can, just to remember really where this stuff comes from. But if you're in a hurry or you're on a test, absolutely do it the easy way. Moving on. So as I mentioned before, that method that I just showed you only works for expressions where the coefficient of the x squared term is 1. So what if we have something like 4x squared plus 9x plus 2? So just like last time, we're going to have two mystery variables, which we'll call a and b again, that we're going to find. But there's different criteria for it this time. So a plus b is still going to equal our middle term, which in this case is 9. But this is where it gets a little bit different. A times b does not equal the last term. It equals the product of the first term, the coefficient of the first term, I should say, and the last term. And you may notice something interesting, which is that these methods aren't actually different at all, because if the coefficient of the first term is 1, then the product of the first term and the last term is just going to be equal to the last term, right? So even though you can't use that like cool short method that we did, it's basically the same method if you use the full expanding out version. But I digress. Let's continue. So if we use our brains, we can figure out that in this case, A is equal to 8 and B is equal to 1. Once again, it works the other way. Communicative property, you know. So now it's time for step 2, which is just expanding it out. So we'll take that 9x term and we'll split it. So 4x squared, we'll split that 9x into 8x and 1x, or just x. I'll write it as 1x just to keep the fact that 1 is there in mind, and then plus 2. And now we just factor by grouping, right? So we can take out the greatest common factor here is 4x. So we have x plus 2. And the greatest common factor for these two is just going to be 1, which, yes, you can do that. And so we'll have x plus 2 here. Then we take out the greatest common factor of x plus 2. And for our final answer, we end up with 4x plus 1 and x plus 2. So there's not that super easy like shortcut version like there was when the coefficient of the first term was 1. But hey, this isn't bad either, and it really makes you think about where it's coming from. So that's all I have for you in terms of factoring with trinomials. Hopefully that was helpful. And yeah, thank you so much for watching my video. I appreciate it. And there's going to be a part 3 to this factoring series. And I'm going to go over recognizing patterns that can make factoring easier, and also the infamous task of completing the square.